Hello students, today I am going to cover up introduction of operating system. So in this video we will cover up the following: computer and computer system, definition of operating system, serial processing, batch processing, spooling, some basic definition that are required to discuss about the operating system, and last one is the virtualization. So firstly I am going to cover up the computer. A computer is basically a hardware that takes some input, processes it, and produces some output. The output may be taken from the internal or external devices, internal device such as hard disk, or external device such as scanner, pen drive, or any another machine. And after processing the data, it may store on the internal devices such as hard disk, or may send the data to any external devices such as printer or any another machine. So here let us go through the definition. A computer is an electronic device that manipulates the information or the data. It has ability to store, retrieve, and process the data. It includes input and output hardware. So it is totally a computer that has the some input devices, some output devices, and the processor perform the operations or execute or manipulate the data. Now, coming on the computer system and its component. In generally, whatever we see or the touch in the hardware is known as the computer. For example, motherboard, keyboard, RAM, processor, printer, scanner, keyboard, mouse, each and everything is treated as the hardware. So this basically makes the or defines the computer. So here the computer system consists of four parts or four components: a user, an application program, operating system, and hardware. The user interact with the application program, and the application program interact with the operating system, and then after operating system interact with the hardware. So whenever a user want to do some operation or want to access some hardware, it must interact with the some application program and then after operating system. A user cannot directly interact with the hardware nowadays in general, but when we are working at the machine level we can interact. But in general, whenever whatever the devices we are using, whether it is a laptop or mobile phone or desktop, whatever it may be, in general we all have the operating system to interact with the hardware. So let us consider an example. Suppose that I am making a C program and I want to store a value I is equal to 10. The value will be stored in the RAM. So RAM is a hardware. So user has to make a program. That programs will be written in some of the application such as text editor or C compiler, etc. That application program will interact with the operating system, and operating system will store the data such as RAM, the value I is equal to 10 at the particular or the specific location. So these are the four component: user, application, operating system, and hardware of the computer system. Now, let us discuss in detail these components. The hardware may be CPUs, that means processor, input-output devices, controller, bus, memory, etc. The operating system contains number of modules, kernel such as kernel, device driver, etc. Kernel. Kernel is the most important part of the operating system that brings up into the main memory as the system get starts and remains until the system will not get shut down. So kernel is the part of the operating system that continuously resides in the main memory until the system is on. Application program or the system utility may include such as Firefox, basically we can say Internet Explorer, Firefox, Chrome, that means a web browser, software language compiler, database systems, and system utilities such as defragmenter, etc. The users may be a person, human being, or a machine that interact with the computer, that interact with the particular computer on which I am working. So user is not necessarily a human being. It may be a machine or some other computer or maybe some other device from which I am getting the input. Now, definition of the operating system. An operating system is a program that manages the computer hardware. It also provides basis for application program and act as an interface between computer and the computer hardware as we have discussed. The operating system performs some basic tasks such as controlling and allocating the memory, instruction priority, which process may have to execute first, maybe may which may get execute second one and which may get later one and so on. So system process in general always has the highest priority than the user process. It also controls the input and output devices. It provides the networking facility. It manages the files and file system. So we will discuss these in the lecture number 2. So here is a basically user and that works with the interact with the application program and application program interact with the operating system and our operating system interact with the hardware. The widely used operating system are Windows family. The Windows family includes Windows 95, Windows NT, Windows 98, Windows Millennium, 2000 XP. Nowadays, the most commonly used is the Windows 10. Along with that, Apple, Macintosh, Android, mostly we are using the Android phones. Along with that, a free software, open source software. Open source means the code is available. We can download that code, manipulate the code according to our requirement, recompile it and execute it. So Linux is a open source software. Along with that, Unix, novel NetWare, etc. are the operating systems that are widely used nowadays. So, task of the operating system. So, operating system perform the memory management, process management, input-output management, network management, device management, file and file system management, authorization management. These all we will cover up in the lecture number 2. So you can say these are the functions of the operating system or services of the operating system. These we will cover up in the lecture number 2. Function of the operating system. Sometimes it is said, explain, operating system works as an government. So like a government, it do not perform any task itself. It controls the various devices that are participating in the operation, such as data buses, which data has to allocated to particular bus, which data has to fetch from the primary memory to the CPU, hand over to the CPU, or brings the data from secondary memory to the primary memory, and so on. So operating system works as a government, means it basically perform the control over the hardwares. So in another word, we can say it works as a resource allocator, means which resource must be allocated to which process. A number of processes may be executing simultaneously. For example, I am listening a song, I am copying a file, I am writing a program. So what resource may allocated to a particular process? In another word, it works as a control program, means controls the execution of the user program. If I am listening a song or copying a file, so this is a process. So when my process will get executed, so this is controlled by the operating system. So sometimes you may ask, discuss, or justify the statement operating system works as a government. So you have to explain the process, how it controls the various resources and coordinate among them to perform some operations. Now I am going to cover up evolution of operating system. So firstly, I am covering the serial processing. As its name shows, processing in the serial order means whatever the instruction is given to the system first, it will get executed first. Then after, when it will get completed, the second instruction will get executed, then after third, and so on. So serial processing operating system perform the instruction into a sequential manner. All the instruction those are given by the user will be executed by using FIFO manner, means first in first out. In the olden days, user, or we can say end user, cannot interact with the computer because the computer was very costlier. A person have the computer, it hires an operator that have the knowledge how the system or the machine or the computer will work. So the operator will take the input from the end user. The input means program. That programs is must be written into the punch card. A punch card will have all the basic inputs such as A, B, C, D, E, F, G, H, and a special symbol along with the 1, 2, 3, 4 numerical value and all. These are represented in the 7-bit ASCII form, bit 1, bit 2, bit 3, and so on. And this is the parity bit. So it is a 7-bit representation. So firstly, the punch card is prepared for the input program, and these punch cards are arranged in the sequential manner and handed over to the operator. The operator will execute the program of the user by inserting the punch card one by one and returns back the output to the end user. In this entire system, sorry, uh, the user cannot interact with the system. Then after, there comes the batch processing. Batch processing, basically, in the older days, only one compiler can be loaded at a time. So suppose that I have two C program, two Java program, two Pascal program, and three COBOL program. So firstly, this can be very betterly explained with the example. Suppose that I have Java program 2, C program 2, Pascal program 3, and COBOL program 2. So these are the program. So when a user want to execute this program, it will hand it over to the operator. Operator will, this is the computer. Operator will firstly load the Java compiler on the system. Then after, it will get the output. Whatever the output, it will compile it and return back to the end user. Then after, there comes is C program. So it will load the C compiler on the machine. This is the machine or computer. Then after, execute that and return back the output to the end user. Then after, it will load the Pascal compiler on the computer and return back the output to the end user of that has submitted the program. So loading and unloading involves, or there is a wastage of time during the unloading and unloading of the compiler. So there is a best way we can make the bunch or batch of the program. Suppose that I am waiting until there should not be at least two program of any specific type I am not going to execute. I am the operator. So whenever there is a two or more the Java program, I will load the Java compiler and then after execute that program and return back the output to the user. Then after, I will load the second Java program and execute it and return back the output to the user. And then after, I will load the third Java program and return back the output to the user. Now all Java program has been executed. Now I will unload the Java compiler and load the C compiler. Then after, I will execute the rest. I will execute the C programs. For example, first C program, then second C program, and then after, I will unload the compiler. Then after, I will load the Pascal compiler and execute the Pascal program. So that means the programs submitted by the users are the known as the jobs. The operator will make the batches of job. This is the Java program job. This is the C program job. And then after it will execute the programs one by one. So let us discuss the definition. Batch process, a batch operating system were designed to control the mainframe computers. The user do not interact directly with the computers, but prepares the job with the program data and some control information and submit to the computer operator. The operator prepares the batch of the jobs that I have discussed. That what are the similar types of the job? It will make the batch, load the corresponding compiler for the execution, run the batch program. That means firstly it will execute the all C compiler Java programs. Then after it will execute the C programs. Later time, the output appeared and consisted of the result or the error message. It will hand it over to the end user. So the utilization of the computer will get increases because there is a wastage of the time during the loading and unloading of the compilers. Nowadays, in our machine, a number of compiler can reside simultaneously in the main memory, but in the olden days this was not possible. So to overcome the problems associated with the serial processing, the batch processing comes into the existence. Still, batch processing have some drawbacks, such as the processor has the higher processing speed than the punch card input speed. Means punch card basically basically punch card reading system is a electromechanical device that reads the input, but the processor is a electronic device that has the higher processing capacity or the capabilities. It performs the works very faster than the punch card reader. So most of the time the CPU spends ideal. To overcome from this problem, the spooling concept comes into the existence. Spooling means simultaneous peripheral operation online. That means a number of operations are executing simultaneously. As its name shows, simultaneous means number of operations. Peripheral operations means we are performing the operations on the peripheral online, means continuously. Spooling refers to the process of transferring the data by placing it into the temporary working area. In general, it is the hard disk from where another program may access it for the processing at later point in time. For example, if the data from the card reader is read by the card reader system and stores on the hard disk. The hard disk is also the electromechanical device, but it has the faster speed than the card reader. So it will the hard disk will store the data from the card reader, and whenever there is a need to perform some operation, the data is brings from the main from secondary memory to the primary memory and executed by the processor. If I will send this data directly to the printer, again printer is very slower, has the slower speed. So CPU has to wait, or there is a wastage of the time because CPU cannot perform some another work. So it is better after processing the data, it will store the data back to the hard disk, and then after the CPU will generate an interrupt to the printer for printing the output. So the speed, there is some matching or to overcome from the mismatch speed of the card reader and CPU or printer or the CPU. We were using in the older days spooling concept. Spooling refers to putting the job in the buffer, a special area in the memory or on the disk where the device can access them when it is ready. Spooling is useful because device has the different data rates. The card has the different data transfer speed, processor has the different processing speed, and printer has the different processing speed. The buffer provides a waiting station where the data can rest while the slower devices catch up. So this is the waiting area for the data. This temporary working area would be a file or the storage device. So this may be possible. It is reading the data from the card. And when sufficient data is stored on the hard disk, it is the processor is executing the data and storing back on the hard disk and also printing that same result to the printer. So simultaneous operation are going on, reading, printing and processing. So that's why it is known as the simultaneous peripheral operation online. Some basic definitions that are used for the discussion of the operating system. Multi-programming. When more than one program can reside in the main memory. In the present scenario, all the laptops or the operating system that we are or the desktop that we are using can have a multiple programs into the main memory. So multi-programming means more than one program are residing in the main memory and they are executing simultaneously. Although a processor can perform one work at a time, but the speed is so fast we cannot judge whether it is doing one task at a time or number of tasks at the same time. For example, we are copying the file, we are listening the song, we are making the program. So we are performing all tasks simultaneously and it looks the processor are doing all work simultaneously. But this is not true. The processor can perform one task at a time. So in the multi-programming, more than one program can reside in the main memory. This we will discuss in detail in the unit number 4, that is your memory management. Multiprocessing. In general, a computer have the single processor. Perhaps you have listened the name of the processor P1, P2, P3, P4 Pentium series. So there were only a single processor. But nowadays, a number of processor may resides on the motherboard. So there comes a concept of the parallel processing. Each processor is is capable to perform different job at the uh, a, uh, a processor is capable each processor is capable to perform a single task at the same time. So number of tasks may get executed simultaneously. Multitasking. As I have discussed, multitasking means a number of tasks are performed simultaneously. Means I am listening the song, I am copying a file, I am making a program. So these all jobs are doing simultaneously. So this is the concept of the multitasking. Now there is a concept multi-threading. When I am copying a file, So we finds which file is copied from source folder to the destination folder. There is a progress bar. There is a time remaining. So the copying is a process, and in the sub process, the thread is a sub process. Basically, a thread is given to the progress bar, a thread is given to the time remaining, a thread is given to the file that is flying from folder number 1 to the folder number 2. So it looks key a number of tasks are performing simultaneously. Basically, it copying is the only single task, but there are a number of threads. We will discuss the threading concept in the lecture unit number 2 in the detail. Time sharing. When two or more jobs are executing simultaneously by the CPU, so it switch overs from one task to another task or one job to another job. So there is a time sharing, means this may be possible. The CPU may perform the 5 tasks, and there is a time slot slice 2 millisecond for each process. So process P1 it will perform for 2 millisecond, then after 2 millisecond it will allocate to the process number 2, then after 2 millisecond to the process number 3. So a number of tasks may get executed simultaneously. So there is a time sharing for the processor. Means the processor time is utilizing by the number of tasks. Now, multi-user. In Windows 95, there was, or Windows 3.1, we can say, there was a single user system, or we can say DOS is also the single user system. In the single user system, only one user can log in and perform the task. While in case of multi-user system, more than one user can log into the system simultaneously. This is my laptop, and at present only I am working on this. Suppose that I have start downloading a file, and then after I have uh, basically switch user, use the option switch user, and another user may enter its valid login name and password, and it may start its working. So the computer thinks two users are working simultaneously, or in general a printer is attached to the particular computer in the lab, and these are the number of users. These can give the print to the printer. So multi-users means all the users are get connected to the particular server, a particular computer that is known as a server, and perform their operation. In multi-user operating system, more allows more than one user to log in the computer simultaneously. The operating system makes sure that the requirements of various users are balanced. Means there should be a particular time slotted allocated for the each user. This should not happen. Only it is performing one user task only. So there will be a condition of the deadlock for another user, or the second user or the third user may comes into the starvation condition. So this should not be there. All the resource must be released after certain time of interval, so that those resources may be used by the another user. Uh, and each of these programs they are using has sufficient and separate resources, so that the problem with one user does not affect the entire community of the user. So multi-user operating system examples are the Unix, Windows, Novel, NetWare, mainframe, etc. Advantage of multi-user: more than one user connected to the server at a time, efficient utilization of the processor as we have discussed. Disadvantage: if suppose that this communication link gets failed, so this cannot communicate with the server, so automatically its work will get stopped. See, whenever we are using the networking, so there is a always security issue. Now, multitasking. Multitasking means more than one task can performed by the user, by the processor. Those tasks may be given by the single user or may be given by the different users. For example, here I am using a browser, I am using a Excel file, I am also working on the MS Paint, I am running a movie on the media player. So these are the number of tasks that are going to perform simultaneously by the processor or the CPU. So this comes under the category of the multitasking. Multitasking operating system allows more than one task to execute simultaneously. The operating system uses different scheduling algorithms to manage and coordinate among the processes. Example of the multitasking operating system are the Unix, Linux, virtual memory systems, VMS, Windows, novel NetWare, etc. So these are the example of the multitasking operating system. Advantages of the multitasking system: time sharing between the different user or the processes. Memory protection for each process means a process cannot overlap the another process area. Each process has the predefined area in the memory that can decide in only that. The process can be run in the background. For example, the Windows Defender is continuously executing in the background. If there is any virus attack, so it will automatically detect and warn a message through a message this virus has attacked. Virtual memory, better resource utilization. Disadvantage means it has the limitation basically of the processor. If the processor has limited processing speed, suppose that a processor can execute 4 tasks simultaneously, but I have given the 10 tasks. So it will spend its most of the time in the switch overing. So automatically the performance will get degraded. So multitasking means we have to check how many process can reside in the memory, if all the processor can execute, if the process are more than that in the main memory, so we have to swap out or stop those processes so that process can utilize its efficiency and produces the output. Now, multiprocessing, as we have already discussed, in the multiprocessing, more than one processor will be there. Here, a symmetric multiprocessing. In the symmetric multiprocessing, each processor have each processor shares the same memory. So this is the possible basically in the tightly coupled systems, means within on a or we can say on a single motherboard. This is possible. While in case of asymmetric multiprocessing, there is a master and there is a slave. So master controls the slave. There is no shared memory. Each processor have its own memory area. This we will cover up in the lecture number 2. So multiprocessing refers to the ability of the system to support more than one processor in the system. The applications in the multiprocessing system are broken into the smaller routines and run independently. The operating system allocate these threads to the processor, improve the performance of the system. The example of the network operating system. Basically, Windows, Linux, Unix all have the multi-process capability of the multiprocessing system. Now, coming on the last topic, that is virtualization. Virtualization means we can run a number of operating systems simultaneously. At present, I am using only one operating system, that is Windows. If I want to run a number of processors simultaneously, uh, number of operating systems simultaneously, then there is a need of the virtualization software. So these virtualization softwares are the VMware, VirtualBox, Parallel Desktop, etc. So coming on the definition, virtualization is a technology that allows us to abstract hardware of the single computer, that is CPU, memory, disk device, network interface card, and so on, into a different execution environment, thereby creating the illusion each have the separate environment is running on its own private computer. For example, I am using here the virtual VMware as a virtual machine software. So it will starting. Yeah, it has been started. Now I am running Kali Linux on it. So I am powering on it. So it is getting power on. So you can see I am running one operating system. I am running another operating system on the a Windows operating system, that is my Kali Linux. Along with that, if I want to execute one more operating system, I can run that also. Suppose that I have the at present I do not have the another operating system. If I will have the next operating system, I can run that also. So number of operating system I can run parallelly. So this if I am making the a C program on Kali Linux and executing it, so it gives me the illusion the hardware is allocated to dedicatedly me. But this is not actual case. There is a only single lamp that is not allocated to the Kali Linux, that is used by the Windows also. If I am using the another different operating system, that may be running on that. So I am closing here. This one I will discuss in the theory classes this in the detail. I am powering off this virtual machine and coming back on the slides. So virtualization provides the virtual environment to execute more than one operating system execute simultaneously. Here you can better understand by the example. In the standalone system, I have the hardware, and above that I have the kernel or the operating system, and then uh, above that we have the number of processes that are going to execute. So this is the basic on the single architecture operating system. Here I have the hardware on which I have installed the operating system to interact, and over that I have installed virtual machine software. Basically this is given here VM1, VM2, VM3. We can run we can run only a single machine also, and on that I can run the number of operating systems simultaneously. Here in the diagram, they are using the number of virtual machine they have installed, but this may be possible. I am using the single virtual machine. For example, this can be understood by the example. Suppose that this is the hardware on which I have installed the OS, that is my Windows 10, and on that I have installed VMware, and on this I am running a number of operating system. Here I am using the Kali Linux, here I am using the Ubuntu, here I am using the Red Hat. So I can run a number of operating system simultaneously, and each of these operating system, Kali Linux, Ubuntu or Red Hat, these will use the same hardware. But for the interaction with the hardware, firstly it will interact with the virtual machine, that is the VMware, and VMware will interact with the OS, and OS will interact with the hardware. So this is the process how the interaction will take place. So do not get confused with this diagram. Here should be a special virtual machine for each one. No, it is not necessary. I have installed only the VMware, and on the VMware I may run on the number of operating system parallel. So now, advantage of the virtualization: efficient hardware utilization means I am using the number of hardware operating systems simultaneously on the different platform. Energy saving: if I am using I have installed the 10 computers and a operating system on each. For example, on one I have installed the Kali Linux, second one on Windows, third on the third Ubuntu, fourth Red Hat, fifth uh, for example Unix, sixth one Mac, and so on. So I have installed the different operating systems. So firstly, the cost effective, it is a cost effective because I am running all operating system on the single machine. Energy saving because I have to give the power to the different operating system or the different machines individually. Here I am giving the power to the only one machine. Effective utilization of the space in in NOC. Basically, effective utilization of space means it requires less space because there is a only single machine. Deploying server is very easily. I can run a number of machines simultaneously, and the other client can communicate with this server, whether it wants to use the Linux, Windows, or Ubuntu, and so on. Disadvantage: the server must have the higher processing and storing power. When a number of operating systems are running simultaneously, so there is a need of the higher processing speed memory, because whenever a process want to get execute, it must bring into the main memory. So all operating system will be in the same RAM or share the same RAM. So in that case, the capacity of the RAM must be higher. Similarly, processor will switch over from one OS to another OS. That's why processor must have the higher processing capacity. Another disadvantage, the speed may get slow. If the processor or the memory is not sufficient, in that case it will respond very slowly. So this is the disadvantage. So this was all about from my side for the lecture number 1. If you have any query, you can contact to me. Thank you.